Good morning, friends. Last we discussed the numerical of exercise of chapter 12 atoms. Now up to the 12.6 we discussed. Now the 12.7 numerical of exercise. Using Bohr's model, calculate the speed of the electron in hydrogen atom in first, second and third orbit. And also calculate the orbital period in each of these levels or these orbits. Now, we have to find out what is the speed of electron when the electron revolves around the nucleus in first orbit, second orbit or the third orbit. Right? For that purpose, first, how we first derive or write down the equation of speed of an electron in nth orbit. For that purpose, we know that when the electron revolves in nth orbit, orbit is circular. Therefore, the necessary centripetal force is provided by the Coulombian electrical force by the nucleus on the electron. Right? Therefore, the necessary centripetal force for circular motion in nth orbit is provided by the nucleus provided by the Coulombian force by the nucleus on the electron. Therefore, mvn square upon r n is equal to k z square upon rn square. Centripetal force is mv square upon r. Here in nth orbit the speed of an electron is Vn and radius of nth orbit is r. Now Z is the atomic number of the element. Therefore the charge of the nucleus is Ze and charge of the electron is E. Actually here the K Ze into E upon r square. Rn is the radius of nth orbit. 1 times r is cancelled. So we can write this equation in that form. M Vn square Rn is equal to K Z square. Take the Rn here. Therefore, the left hand side of this equation is written as M Vn Rn into Vn is equal to Z square K or the K Z square. For hydrogen atom, Z is equal to 1 and from Bohr's postulate, mvn Rn, angular momentum is integral multiple of h upon 2 pi. Therefore, mvn Rn is equal to nh upon 2 pi. Substituted in this equation, therefore we obtain nh upon 2 pi into Vn is equal to K square. Z is equal to 1 for the hydrogen atom. Therefore, Vn is equal to our equation of speed of an electron in nth orbit. Vn is equal to 2 pi K square upon nh. There is our equation number 1. There is the general equation of speed of an electron in nth orbit 2 pi K square upon nh. Okay. Therefore, the speed of an electron in n is equal to 1 orbit of the level is substitute the n is equal to 1. Therefore, V1 is equal to 2 pi k square upon h. There is our second equation. Substitute the value of k, 9 into 10 is to 9, e, 1.6 into 10 is to minus 19, h, 6.625 into 10 is to minus 34. Therefore, V1 is equal to pi 3.14, k, 9 into 10 is to 9, into e square 1.6, 10 is to minus 19 whole square, upon Planck's constant 6.625 into 10 is to minus 34. Thus we obtain the V1 is equal to 21.85 into 10 is to 5. That means the 2.185 into 10 is to 6 meter per second. That is the speed of an electron in first orbit. That is our V1. Clear it? Okay. Now, in equation 1, H is substituted the value of 2. 2 pi k square upon H is equal to V1. Now, substitute equation 2 in 1. Equation 1 is this, Vn is equal to, instead of the 2 pi k square upon h is equal to V1. So V1 upon it. That is our general equation. V1 already we obtained, divided by the number of orbit, we obtain the speed of electron in different orbit. That means either 1, 2, 3, 4, 5 and so on, any orbit. Therefore, speed of an electron in n is equal to 2 level for the second orbit is V2 is equal to V1 by 2. Is V1 by 2. V1 already we obtained 2.185 into 10 is to 6 divided by 2. So is equal to 1.092 into 10 is to 6 meter per second. That is the speed of an electron in second orbit. Similarly, speed of an electron in n is equal to 3 level is V3 is equal to V1 by 3. V1 by 3. V1 is 2.185 into 10 is to 6 by 3. That means the 0.7286 into 10 is to 6. 0.728 into 10 is to 6 meter per second. So thus we obtain the speed of an electron in level 1, 2 and 3. Again, our aim is to find out using the Bohr's model, calculate the speed of the electron in hydrogen atom in first, second and third orbit. For that purpose, we consider that the necessary centripetal force for circular motion in nth orbit is provided by the Coulombian force by the nucleus of the electron. Therefore, centripetal force mvn square upon ion is equal to kz square upon ion square. Okay. Now here Vn is the speed of an electron in nth orbit. Rn, radius of nth orbit. K, Coulomb's constant. Z, atomic number of an element. E, charge of an electron. So here 1 times ion cancel. This ion is taken on LHS. Therefore, M Vn square Rn is equal to kz square. For hydrogen atom, just we can add this left hand side term like this way. M Vn into I into Vn is equal to kz square. Okay. For hydrogen atom, take the z is equal to 1, and for Bohr's postulate, angular momentum is integral multiple of h upon 2 pi. That means the m Vn I is equal to nh upon 2. Substitute here. Therefore, nh upon 2 pi into Vn is equal to k square. Therefore, velocity or the speed of an electron in nth orbit Vn is equal to 2 pi k square upon n. Okay. That is our equation. The speed of an electron in n is equal to 1 orbit is, substitute the n is equal to 1 in this equation. Therefore, V1 is equal to 2 pi k square upon h. That is our equation 2. Okay. Substitute the value, we obtain the V1 is equal to 2.185 into 10 raised to 6 meter per second. We can also obtain the speed of an electron in n is equal to 2, n is equal to 3 orbit by directly substitute the value of constant in equation 1. And second method is that in equation 1, 2 pi k square upon h, that is represented by V1 from equation 2. Therefore, we take the 2 pi k square upon h as V1. So this equation 1 becomes the Vn is equal to V1 upon n. That is our third equation. Therefore, the speed of an electron in any orbit is equal to the ratio of the speed of an electron in first orbit to the number of orbit. Therefore, the speed of an electron in n is equal to second level is V2 is equal to V1 by 2. That means the speed of an electron in second orbit is half of the speed of an electron in first orbit. That is the 1.092 into 10 raised to 6 meter per second. Similarly, the speed of an electron in n is equal to 3 level is V3 is equal to V1 by 3 is equal to 2.185 into 10 raised to 6 by 3. That means the third part of V1 0.728 into 10 raised to 6 meter per second. Now B part, we want to derive the equation of periodic time for the orbital period in level 1, 2 and 3. For that purpose, we know that the relation between the linear speed and angular speed. So Vn is equal to Rn into omega. Omega is equal to 2 pi f. Therefore, Rn into 2 pi Fn. We also know that the reciprocal of the frequency is the periodic time, or frequency is equal to 1 upon Tn. Therefore, 2 pi Rn upon Tn. Therefore, the equation of periodic time Tn is equal to 2 pi Rn upon Vn. That is our equation number 4. That is the equation of time period of an electron in nth orbit. We are interested to calculate the time period of an electron in 1, 2 and 3rd orbit. For that purpose, therefore, the orbital period of an electron in n is equal to one level of the orbit is T1 is equal to 2 pi R1 upon V1. Substitute the value 2 pi is equal to 2 pi 3.14. Now, R1 is not given, but we know that for the hydrogen atom, the radius of the first orbit is 0.53 into 10 is to minus 10 meter. Directly we intercept 0.53 into 10 is to minus 10. And already we obtained the V1 2.185 for the 184. 2.185 into 10 is to 6 meter per second. By substituting the value, we obtain 1.523 into 10 is to minus 16 second. That is our first periodic time, or the periodic time of an electron in first orbit. T1. Value of T1. We can also calculate the orbital period in n is equal to 2 and n is equal to 3 orbit by substituting the value of R2, V2 and also R3 and V3. But here we have the no information about the radius of the second orbit and third orbit. Right? For that purpose we convert this equation in short form like this way. Now Rn is equal to n square R1 and Vn is equal to V1 by n. Substitute in 4. Therefore, Tn is equal to 2 pi Rn n square R1 upon V1 upon n. Therefore, 2 pi R1 into n cube upon V1. 2 pi R1 upon V1 into n cube. So that is our T1. This part is T1. Therefore, n cube T1. That is equation 1. Therefore, orbital period of an electron in n is equal to 2 and n is equal to 3 orbits, so the levels are T2 is equal to n, that means the 2 cube into T1, and T3 is equal to 3 cube into T1. 2 cube 8 into T1. T1 is 1.523 into 10 is to minus 16. Right? Therefore, 1.216 into 10 is to minus 15 seconds. There is the periodic time of an electron in second orbit. Similarly, T3 is equal to 9 into 1.523 into 10 is to minus 16 seconds. So we obtain there is the 4.114 into 10 is to minus 15 seconds. So these are the periodic time or the orbital period of an electron in second and third orbit respectively. Again in the B part, what is the relation between the linear speed and angular speed? Vn is equal to Rn into omega. We know that the omega is equal to angular frequency 2 pi Fn. Therefore, Rn into, or instead of the omega, 2 pi Fn. And also we know that frequency is the reciprocal of periodic time. Instead of the Fn, we can add the 1 upon Tn. Therefore, 2 pi Rn upon Tn. Therefore, Tn taken here. Therefore, Tn is equal to 2 pi Rn upon Tn. We are interested to obtain the periodic time of an electron in first orbit. Substitute the n is equal to 1. Therefore, T1 is equal to 2 pi R1 upon V1. 2 pi 3.14 into R1. Already we know that the radius of the first orbit in hydrogen atom is 0.53 into 10 is to minus 10. upon V1, 2.185 into 10 is to 6. Therefore, 1.523 into 10 is to minus 16 second. Now, Rn, radius of the nth orbit is n square times radius of the first orbit, and speed of an electron in nth orbit is V1 upon n. Substitute in equation 4. Therefore, Tn is equal to 2 pi n square I1 upon V1 upon n. N is taken in the numerator. Therefore, 2 pi I1 upon V1 into n cube. But there is equal to over T1. Therefore, n cube T1. Now, orbital period of an electron in n is equal to 2 and n is equal to 3 levels are T2 is equal to, using equation 5, 2 square 2 is to cube into T1. 2 cube 8, T1 already we calculate 1.523 into 10 is to minus 16. Thus we obtain the orbital period of an electron in second orbit is 1.216 into 10 is to minus 15 second. Now, in equation 5, it is substituted the n is equal to 3. Therefore, T3 is equal to 3 raised to cube into T1. 3 cube 27, sorry. Not square, 27. 27 into T1, 1.523 into 10 is to minus 16. That means the 4.114 into 10 is to minus 15 second. Clear? So thus we obtain the radius, the speed of an electron in n is equal to 1 to 3 orbit, and also orbital period of an electron in this level. Okay, now next numerical of exercise 12.8. The radius of the innermost orbit of hydrogen atom is 5.3 into 10 is to minus 10 meter. What are the radii or the radius of the orbit of n is equal to second, n is equal to 2 and n is equal to 3 orbit? That means the radius of the first orbit is given, that is known as the Bohr's radius. We have to find out what is the radius of the second and third orbit, right? Now here, for the hydrogen atom, the Bohr radius is given. Bohr radius for the R0 is equal to A0 is equal to 5.3 into 10 is to minus 11 meter is given. Now we have to find out for n is equal to second orbit. What is the radius? R2 we have to find out, and 4. n is equal to third orbit. We have to find out the radius of third orbit. Now we know that the radius of nth orbit Rn is equal to n square R1. Or in other words, there is the n square R0. That is the Bohr's radius. That means for n is equal to 1. Now, therefore, the radius of n is equal to second orbit is R2 is equal to 2 square R0. That means the 4 into 5.3 into 10 is to minus 11. It means 2.12 into 10 is to minus 11 meter. That is the radius of second orbit R2. And radius of n is equal to third orbit is, we can calculate from this, R3 is equal to 3 square into R0. 3 square, that means the 9 into R0 already given 5.3, 10 is to minus 11 meter is equal to 4.73 into 10 is to minus 11 meter. That is the radius of our third orbit in hydrogen atom. So where is the numerical? In one part is asked for the MCQ type question. Now the radius of the innermost orbit of the hydrogen atom, innermost orbit, that means the first orbit, and this radius is also known as the Bohr's radius, is given 5.3 into 10 is to minus 11 meter. What are the radii of n is equal to 2 and n is equal to 3 orbits? Now for hydrogen atom, Bohr radius or the innermost orbit radius is denoted by R0 or A0 is 5.3 into 10 is to minus 11 meter. For first orbit n is equal to 1. We have to find out the radius of the second orbit and third orbit. Now we know that radius of the nth orbit Rn is equal to n square R1 or the n square R0 because the R1 is denoted by R0. Therefore, radius of n is equal to second orbit is R2. In this equation, substitute the value of n as 2. Therefore, R2 is equal to 2 square R0 is equal to 4 into 5.3 into 10 is to minus 11. That means 2.12 into 10 is to minus 11 meter. And radius of the n is equal to third orbit, substitute the n is equal to 3 in this equation. Therefore, R3 is equal to 3 square R0 is equal to 9 into 5.3 into 10 is to minus 11 meter. Therefore, R3 is equal to 4.73 into 10 is to minus 11 meter. Clear this? After that, we take the 12.10 numerical of exercise. 10.9 we discuss after this. Okay. In accordance with the Bohr's model, find the quantum number that characterizes the Earth's revolution around the Sun in an orbit of radius 1.5 into 10 is to 11 meter, with orbital speed 3 into 10 is to 4 meter per second. We have to find out the quantum number of Earth's orbit. Orbital radius of the Earth and orbital speed of the Earth in particular orbit is given. So as we compare with the atomic model, so what should be the orbital number of Earth? Right. For that purpose, first we write down the mass of the Earth. That is given m is equal to 6 into 10 is to 24 kg. Orbital speed of the Earth, that is given as v, 3 into 10 is to 4 meter per second, and radius of the orbit around the Sun. Radius of the orbit around the Sun is R is given as 1.5 into 10 is to 11 meter. Now, from Bohr's second hypothesis or the second postulate, from Bohr's second postulate. So, angular momentum of the Earth is equal to integral multiple of h upon 2 pi. Therefore, mvr is equal to nh upon 2 pi. Our aim is to find out the orbital number. Therefore, n is equal to 2 pi mvr upon h. Right? Again, from Bohr's second postulate, angular momentum is equal to the integer number of the integral multiple of h upon 2 pi. Therefore, n is equal to 2 pi mvr upon h. So 2 pi 3.14. Mass of the earth 6 into 10 is to 24. Speed of the earth v 3 into 10 is to 4. Radius of the earth is 1.5 into 10 is to 11. Upon h, Planck's constant 6.625 into 10 is to minus 34 joule into second. Thus, we obtain the orbital quantum number is 25.5939 into 10 is to 73. That means 2.6 into 10 is to 74th number orbital. As we compare, the evolution of the earth around the sun is same as the evolution of the electron around the nucleus. So, what should be the quantum number of the orbit of the earth around the sun? So, here the mass, orbital speed and radius of orbit around the sun are given. We are applying the Bohr's second postulate for the earth. Therefore, the angular momentum of the earth is integral multiple of h upon 2 pi. Therefore, n is equal to 2 pi mvr upon h. Now we substitute the value of 2 pi 3.14, mass of the earth 6 into 10 is to 24. Speed of the earth 3 into 10 is to 4, and radius of the orbit of the earth around the sun 1.5 into 10 is to 11. Divided by Planck's constant 6.625 into 10 is to minus 34. Thus we simplify the 25.5939 into 10 is to 73. That means the 2.6 into 10 is to 74. That is the quantum number of the orbit of the earth around the sun. Clearly? Okay.